So now we're going to get into the relationship between the current, the resistance, and the potential difference. And the key thing to realize is that the current is dependent on both the resistance and the potential difference. And so if you were to measure the current through a component using an ammeter like this, then essentially you could also measure the voltage across that component using a voltmeter like this. So the voltage or the potential difference is the same term. In your exams, they'll use the term potential difference, but commonly it is referred to as the voltage. The idea is that the potential difference across the component can be measured using a voltmeter, and the way you do that is you connect the terminals either side of this component, and we call this connecting in parallel, and we talk about this in a little bit more detail in another video. But the key fundamental concept for this video is this equation here, that the voltage or the potential difference across a component is equal to the current multiplied by the resistance. And we can actually label these. So this is your potential difference, this is your current, and this is your resistance. And so, for example, in this circuit over here, we could have a 10 ohm resistor, and then we could have maybe a 5 volt potential difference source. And our current would therefore depend on the potential difference across our voltmeter. So this would also read 5 volts, and the current flowing through and the resistance of the component itself. So let's add some units onto our equation over here. So potential difference is measured in volts, current is measured in amps, and resistance is measured in this symbol we call ohms. And the key idea is that if your potential difference is fixed, then essentially the current will decrease as the resistance increases. And the way we could actually write this is that the current is inversely proportional to the resistance. What that means is that the larger your current is, generally the smaller your resistance, and the larger your resistance, the smaller your current, if you have a fixed potential difference. Okay, so now let's actually look at trying to apply this equation in some questions. So pause the video, have a go at this question. What is the resistance of the resistor if you have an ammeter reading 10 amps over here and a voltmeter reading 3 millivolts across this resistor? What would the resistance be? Well, we can use our equation V equals IR, and so all we need to do really is rearrange for R. So the resistance would equal V over I. And now we can just plug in our numbers. So you'll notice here we've got 3 millivolts. So you want to convert this to volts. So 3 millivolts in volts is 0.03 volts divided by the current of 10 amps. So excuse me, this should be 0.03 volts over 10, and you should get 0.0003, and the units will be ohms. And you can also write this as 0.3 milliohms. Okay, so hopefully you got that one correct, and I'll see you in the next one.